Welcome back, guys. Today we are going to discuss this vitamin, this water soluble vitamin, this vitamin C. Vitamin C is also known as the ascorbic acid, a very important antioxidant. This vitamin C, along with vitamin A and vitamin E, is a very important antioxidant. Next, we're going to see is this: most animals synthesize vitamin C from glucose. Remember, from glucose by uronic acid pathway. Okay, most animals synthesize vitamin C from glucose by this uronic acid pathway from glucose, but we humans and higher primates we can't synthesize vitamin C from glucose. Why? Because of absence of an enzyme. Absence of this enzyme L gulunoate acetone oxidase. L gulunoate acetone oxidase. Due to lack of this enzyme in humans and higher primates, we can't synthesize vitamin C from glucose, and other most animals can synthesize by this uronic acid pathway. So we're going to see some functions of vitamin C, how this vitamin regulates some functions in our body. First is hydroxylase reactions. So it's a coenzyme for copper containing hydroxylases. For example, remember dopamine beta hydroxylase, not carboxylase, it's dopamine beta hydroxylase. Another hydroxylase enzyme, remember peptidyl glycine hydroxylase. These two examples are given in Vasudevan. So dopamine beta hydroxylase and peptidyl glycine hydroxylase, these are copper containing hydroxylases. Next it is a coenzyme for alpha ketoglutarate linked iron containing enzyme. Coenzyme for alpha ketoglutarate linked iron containing enzyme such as proline and lysyl hydroxylase. Remember, these two enzymes are super important for maturation of collagen, proline and lysyl hydroxylase. So this vitamin C is a coenzyme for alpha ketoglutarate linked iron containing enzyme, also for copper containing hydroxylases. So as these two enzymes are involved in collagen synthesis. So there occurs anemia in vitamin C. Why? Because there is vitamin C deficiency. There is anemia in vitamin C deficiency. Why? Because there is decreased hydroxylation of proline and lysine. Proline and lysine are the two amino acids in the triple helix structure of collagen. The hydroxylase done by proline and lysine hydroxylase. This decreased hydroxylation of proline and lysine, it causes a defect in collagen. Causes a defect in collagen, leading to bleeding manifestations. Bleeding manifestations. So there is anemia in vitamin C deficiency. Also remember, vitamin C is also required for reductase activity. Okay, vitamin C is also required for reductase activity. What this reductase does is converts Fe3 plus 2 Fe2 plus ferric to ferrous form, which then gets absorbed. So we can say vitamin C is required for iron absorption. Why? Because it's also required for ferroreductase activity, which converts ferric to ferrous form for absorption. So these are all the important functions of vitamin C. Now we are going to discuss some all important deficiency manifestations. Deficiency manifestations. Okay, first one we're going to see is bleeding gums. Next we have splinter hemorrhage. There is splinter hemorrhage and there is bleeding gums. Then there is hemarthrosis. Next we have pseudo paralysis. Pseudo paralysis, also called as pithed frog appearance. Clinically it is called as pithed frog appearance. Pseudo paralysis. There is pseudo paralysis, hemarthrosis, splinter hemorrhage, and there are bleeding gums. Then we have to see two types of rosary. The first is a scorbutic rosary. Scorbutic rosary. This there is sharp angulations with or without beading. This beading is termed as rosary. This beading is termed as rosary. Sharp angulations with or without beading due to backward displacement or pushing in of sternum. Due to backward displacement of sternum, there is sharp angulations with or without this beading. This is scorbutic rosary. Next type of rosary is rachitic rosary. Rachitic rosary. Here there are bead like enlargement of, remember, costochondral junction. There are bead like enlargement of costochondral junction. Bead like enlargement of costochondral junction in rachitic rosary. Inward pushing or backward displacement of sternum with or without beading, scorbutic rosary. So these are some of the early deficiency manifestations of vitamin C. Next is all important scurvy. We are all familiar with this word scurvy. So what are these manifestations? There is bleeding, there is bleeding gums, splinter hemorrhage as we have discussed above, there is petechiae, there is ecchymosis, there is ecchymosis, there is perifollicular hemorrhage, then there is anemia. First is bleeding, next is anemia, and there is scorbutic rosary. These are some of the important clinical manifestations in scurvy due to vitamin C deficiency. Next we are going to see an important infantile scurvy that occurs in infants. This is commonly called as Barlow's disease. So these infants between 6 to 12 months, okay, when weaning starts, okay, I write this again, weaning, and they are developing, when weaning starts, their vitamin C deficiency occurs. Infants between 6 to 12 months, when the weaning phase starts, there occurs vitamin C deficiency. This is infantile scurvy or Barlow's disease. So they should be supplemented with vitamin C sources. These infants should be supplemented with sources of vitamin C. Okay. Next we are going to see is some dietary sources. Very simple, guys. We all know what are the dietary sources. These are the citrus fruits like lemon, lime, guava, amla, also green leafy vegetables. Lemon, lime, guava and amla. Amla is very important. And green leafy vegetables. Next is the required dietary allowance, which is 75 milligrams per day. It increases in pregnancy and lactation period to 100 milligrams per day. Okay, so this is the RTF for vitamin C. So that's why I advised we should try to take lemon juice in our diet every single day, because RDA is a bit on the higher upwards. So this is RDA, and pregnancy lactation is 100 milligrams per day. With this we have completed our discussion on vitamin C. A small water vitamin, nothing much is there to discuss except its role in hydroxylation reaction and the deficiency manifestations leading to scurvy. Next, we are going to discuss is vitamin E. Vitamin E. We all know this vitamin E, also called as alpha tocopherol. Alpha tocopherol. Vitamin E cells alpha tocopherol. So it has a chromin ring called tocol ring. This tocopherol is tocol ring. So tocol ring plus isoprenoid side chains. Okay, this is chromin ring structure in which the tocol ring is combined with isoprenoid side chains. It's an important, remember, chain breaking antioxidant. Okay, along with vitamin C and A, it's a very important chain breaking antioxidant. So how it does is, it's a lipophilic compound. Okay, it's a lipophilic compound in membranes. Okay, in membranes, it's a lipophilic compound. It protects LDL from oxidation. Okay, protects the LDL from oxidation and protects PUFA, polyunsaturated fatty acids, in the membrane. Protects LDL from oxidation and PUFA in the membrane. All these put together, it prevents lipid peroxidation. Okay, altogether it prevents lipid peroxidation. It's a lipophilic compound in the membranes, protects LDL and PUFA. So this is some of the very important antioxidant functions. Now we're going to see some deficiency manifestations. Deficiency manifestations. Okay, so what comes under these deficiency manifestations? There is axonal degeneration. Due to reduced antioxidant activity, there is axonal degeneration. There is peripheral neuropathy. Peripheral neuropathy. There is spinocerebellar ataxia. Peripheral neuropathy, spinocerebellar ataxia, axonal degeneration. Then there is hemolytic anemia. Why there is hemolytic anemia here? Because see here, as it is an antioxidant, it prevents generation of free radicals. Prevents generation of free radicals. Okay, and an antioxidant prevents generation of free radicals. So in deficiency, free radicals destroy RBC membrane, leading to hemolytic anemia. In deficiency of vitamin E, generation of free radicals degrades the RBC membrane and causes hemolytic anemia. Vitamin E in the eyes produces pigmented retinopathy, ophthalmoplegia, and nystagmus. In the eyes, pigmented retinopathy, ophthalmoplegia, and nystagmus. These are some of the deficiency manifestations of vitamin E. I want to see vitamin E as treatment. Vitamin E is sometimes also used in treatment in, remember, retinolental fibroplastia. Retinolental fibroplastia, also used in intermittent claudication. Also used in bronchopulmonary dysplasia. Also used in to slow aging process. Yes, we have seen this vitamin E serums are used in skin treatments. This slows aging process. Is an important antioxidant. It's one of the function of antioxidants to slow the aging process. So retinolental fibroplastia, intermittent claudication, and bronchopulmonary dysplasia, and also in slowing the aging process. Now you see an important fact here, that is important metal selenium. It decreases the requirement of vitamin E. Why? Because the selenium is present in glutathione peroxidase. Selenium element is present in the glutathione peroxidase. This glutathione peroxidase, we know, it oxidases and destroys free radicals. Okay, it oxidases and destroys free radicals. Selenium and vitamin E synergistically act and destroys free radicals. These free radicals are high energy compounds that causes damage and disease in the body by several processes. The selenium and vitamin E, they act synergistically together and destroys the free radicals. This increased selenium concentration decreases the requirement of vitamin E, because they both act in the same way on the same compound. So there is increased selenium, it decreases the requirement of vitamin E present in glutathione peroxidase. But peroxidase is involved in destruction of free radicals. Okay, now we are going to see some RDA. RDA in the males is 10 mg per day. In females is 8 mg per day. In pregnancy and lactation, it rises to 10 to 12 milligrams per day in females. Okay, the RD of vitamin E. Now we're going to see some toxicity of vitamin E. Vitamin E in excess causes it interferes with platelet aggregation. Interferes with platelet aggregation. Also interferes with vitamin K. These all can produce bleeding manifestations. It interferes with the platelet aggregation as well as with vitamin K cycle. Toxicity of vitamin E in excess can produce bleeding manifestations. This was all about this antioxidant vitamin E. This small topic, nothing much to know. So it's an important antioxidant. The role of selenium, the toxicity, and how it prevents lipid peroxidation in the membranes, being a lipophilic compound. Small but yet important topic. Next we are going to see last vitamin in this discussion, vitamin K. Okay, I'm going to discuss now vitamin K. This vitamin K, remember, is derived from German word coagulation. Coagulation is a German word. From this K, vitamin K is derived. Okay, these vitamin K compounds are naphtha-quinone derivatives. Okay, naphtha-quinone derivatives. This vitamin K has three forms, three very important forms. Vitamin K1, first form called phylloquinone. These are from dietary sources. Okay, vitamin K, phylloquinone. Write this again. Phylloquinone. Second form is vitamin K2. This is called menaquinone. This is from, remember, bacterial flora. Vitamin K is one of the rare vitamins that is derived from the bacterial flora. Vitamin K2, menaquinone. Vitamin K3, this is called menadione. This is a synthetic water soluble vitamin K form. So synthetic water soluble vitamin K form, menadione, is vitamin K3. These are three important forms: phylloquinone, menaquinone, and menadione, from dietary sources, bacterial flora, and menadione is synthesized synthetically. Now I'm going to see some functions of vitamin K. Functions is very important. Listen, it is involved in post translational gamma carboxylation of glutamic acid. Post translational, after translation, gamma carboxylation at the gamma position of glutamic acid Y is in, remember, are the clotting factors of factor 2, factor 7, 9 and 10. Factor 2, 7, 9 and 10. Okay, there is protein C, protein S. Okay, then also nephrocalcin in kidney and osteocalcin in bones. Lastly, of gas 6, this is growth arrest specific gene product. So of all these proteins and compounds, there is post-translational gamma carboxylation of glutamic acid. The clotting factors are factor 2, 9, 7 and 10 to 7, 9 and 10, protein C and protein S involved in, remember, coagulation. Very, very important. These 4 factors we need to remember always. Also of nephrocalcin produced in kidneys and osteocalcin from bones. And a gas 6 gene, growth arrest specific gene product. Okay, these are the most important function of vitamin K, post-translational gamma carboxylation of glutamic acid. Now we are going to see an all important vitamin K cycle. Okay, vitamin K cycle. So we start with a protein getting gamma carboxylated. Okay, what is this protein? This protein is none other than our glutamic acid. After gamma carboxylation forms gamma carboxy glutamate. Okay, forms gamma carboxy glutamate. Glutamic acid is the protein. After gamma carboxylation produces gamma carboxy glutamate. Along with this, another reaction takes place, which is this is vitamin KH2. Okay, this is hydroquinone. H2 for hydro, and this is a quinone derivative vitamin K2. Vitamin K2 is hydroquinone. This is converted to, along with this glutamic acid to gamma carboxylation reaction, converted to vitamin K epoxide form. Very, very important. Vitamin K epoxide form. In further reactions, this vitamin K epoxide is converted to simple vitamin K called quinone. Okay, and what is the enzyme here? The enzyme here is vitamin K epoxide reductase. Vitamin K epoxide reductase is the enzyme for conversion of vitamin K epoxide to vitamin K. Finally, this vitamin K quinone form converted to vitamin KH2 hydroquinone. And what is the enzyme here? This enzyme here is simple vitamin K reductase. Epoxide to vitamin K epoxide reductase. K to hydroquinone, vitamin K reductase. These are the two most important enzymes in the vitamin K cycle. Now, the important fact you need to remember here is this vitamin K epoxide reductase. Okay, this enzyme is inhibited by some drugs. What is the name of those drugs? Inhibited by, remember, warfarin and dicumarol. Warfarin and dicumarol. These two are, remember, structural analogs. So warfarin and dicumarol are the structural analogs, and we know structural analogs causes competitive inhibition. Very, very important. So this warfarin and dicumarol causes competitive inhibition of vitamin K epoxide reductase, which leads to prevention of gamma carboxylation of proteins. As this enzyme is inhibited, this whole gamma carboxylation process of proteins is inhibited. So this is the all important vitamin K cycle. The two enzymes, vitamin K epoxide reductase and vitamin K reductase. Vitamin K epoxide reductase is inhibited by warfarin and dicumarol. These two drugs are structural analogs which causes competitive inhibition, thus preventing gamma carboxylation of proteins. So next we are going to see some deficiency manifestations. As is involved in maturation of the clotting factors. Deficiency manifestations include increase in prothrombin time. Okay, increase in prothrombin time and increase in bleeding time, BT. Prothrombin time, P sub T and T. BT and PTT, there is increase in prothrombin time and bleeding time. Then very common bleeding manifestations. Okay, there are bleeding manifestations. Important note arises here: why newborns are susceptible to deficiency of vitamin K. Vitamin K, why the newborns are very susceptible to its deficiency? Let's see this. First reason, there is decreased fat stores. Fat stores are required for transportation of vitamin K. Okay, there's decreased fat stores which are required for transportation of vitamin K. Second is sterility of gut of the newborns, and as we know, vitamin K2, we have discussed above, is produced by bacterial flora. Third reason is the breast milk is a poor source of vitamin K. The fourth reason is there is very less placental transport of vitamin K. There is very less placental transport. Vitamin K is not transported across the placenta. There is less placental transport, and finally there is immaturity of the lungs. There is immaturity of the lungs. So these are the 5 reasons Why newborns are susceptible to deficiency of vitamin K. First is decreased fat stores, sterility of the gut, that's why vitamin K2 can't be produced. Breast milk is a poor source of vitamin K. Then there is less placental transport. And finally, there is immaturity of the lungs in the newborns. The another scene we are going to discuss is vitamin K toxicity. Okay, vitamin K toxicity, remember, causes hemolysis. In excess of vitamin K, it causes hemolysis. How? Hemolysis, which further causes hemolytic jaundice. Hemolytic jaundice due to destruction of the hemoglobin. Hemolytic jaundice. There is increased bilirubin in the bloodstream. This bilirubin in infants, remember, crosses the blood-brain barrier. In infants, it crosses the blood-brain barrier, causes a condition called kernicterus, affecting basal ganglia. Okay, affects the basal ganglia. This condition is called kernicterus, leading to brain damage. Leading to brain damage in infants. Condition is called kernicterus due to increased bilirubin due to hemolytic jaundice, hemolysis occurs in vitamin K toxicity. The last topic I am going to discuss here is the RD of vitamin K. It is nearly very less 1 micrograms per day, or you can say 1 micrograms per kg of body weight. It's the most accurate form. It's 1 micrograms per kg of body weight, which is roughly 55 to 65 micrograms per day. Okay, this is the RD of vitamin K. So sources, if you are going to see, there is green leafy vegetables, some are probiotic supplements which enhances the gut bacterial flora, fruits, legumes, yeast, etc. These are some of the sources of vitamin K. With this, we complete this vitamin module. We discuss vitamin C, then we discuss vitamin E and vitamin K. Vitamin E and vitamin K, some of the most important antioxidants. Vitamin C involved in collagen maturation, hydroxylation reaction. Discussed all their efficiency manifestation. Very small topics, but contain some important information. Please do revise them. Thank you. I will catch you in the next one.